Chapter 5 is about selecting research participants. Definition of sample and population is sort of easy. A population is the entire set of individuals of interest to a researcher, and a sample is a set of individuals selected from that population, and usually it's intended to represent the population in a research. If the sample that we choose is a representative sample, it means most of the characteristics of the sample is the same as the population, so we call it a representative sample. Otherwise, we call it a biased sample. So a biased sample is a sample with different characteristics. And if you have a biased sample, that means that you have some sort of selection bias, which means that you had done something in your sampling that resulted in a biased sample. One question, and sort of important question, that students ask when they want to do research is, what should be the size of my sample? How many individuals I need in my sample to be large enough? The answer is simply the larger the better. However, most of the time it doesn't make sense to have a huge number of individuals in your sample. So you always have to consider practical limitation, the cost and the time of doing research with an extremely large sample. So usually when you are concerned about doing a statistical analysis, it's recommended to have a size of 25 or 30 individuals for each group in your treatment conditions. However, remember that in a lot of research studies we have more than one group, or we have several groups with different factors that we want to consider. So the more the number of groups that we have, and the more the number of variables and factors that we want to consider, probably you want to have a larger number, because if you don't have enough enough individuals in your sample, then you're going to have problems in your analysis later when you want to compare groups. There is a magic number that researchers believe is an optimum number for most large-scale research studies, and that number is 384. So in a large-scale research, like a statewide research or nationwide research, they say that 384 is a magic number, and the reason is that, as you see in this chart, when, for example, you have only 30 or 40 sample individuals in your sample, the margin of error is about 20%, okay, between 10 and 20%. And as you increase the size of your sample, when you reach like 80 or 90, you reducing the margin of error to about 10%. And when you reach the number like 380 around here, you see you have about 5%. And it's interesting that after this number, as you increase the number of individuals in your sample, you don't get that much reduction in your margin of error. That's why they call this a magic number, because any number above that number doesn't help you. It's always helpful, but doesn't help you that much in terms of reducing the margin of error. This is the same idea in a different format that shows when, for example, here the sample size is 96, the margin of error is 10%, and when it's 384, the margin of error is 5%. We have different methods for sampling that depending on situation we use a different type of sampling. In general, the sampling methods are categorized into two main categories of probability sampling and non-probability sampling. The probability samplings are the kind of sampling that somehow some sort of randomness is involved. But the non-probability sampling is when you use like your accessible or available group of individuals. This table, which is from the textbook, shows 5 types of probability sampling. The first one is a simple random. Simple random is when you have a list of all individuals in the population and then you randomly select a portion of it, like 100 individuals from that, and it's absolutely random and everybody has an equal chance to be selected to participate in the research. A similar method is the systematic sampling. In the systematic sampling method, we choose students based on a list, but instead of doing it random, we do it by selecting the nth participant from a list. Like, for example, you have a list of 1,000 students, you select number 1, number 50, number 100, number 150, number 200. Every 50th student is selected to participate. The other method is a stratified random. We use this method when we want to make sure that we have enough participants from each group, because if you do random sampling, you may not get enough Latino or enough black student in your sample. So you want to make sure that we have like equal percentage of white and black and Latino student in your sample. So if you're choosing like 100 people from a campus, you make sure that 33 individuals are white and 33 individuals are black and 33 individuals are Latino. A similar method is proportional stratified. It's similar because you have specific percentage of individuals, but these percentages are totally different from stratified random, because in stratified random you want to make sure that the percentage of individuals from each group are equal, but here you want percentage of each group be somehow similar to the population. So for example, if in the actual population we have 10% black, we want in our sample also to have 10% black. Another type of probability sampling is the cluster sampling. Cluster sampling is, instead of choosing random individuals, we use random clusters or random groups. For example, if you want to do a nationwide research on elementary school, you cannot have the list of all elementary school students in one list. So what you do, you randomly select 5 states, and then in those 5 states you randomly select like 5 school districts, and those 5 school districts you randomly select 2 schools, and then in those schools you can randomly select like 20 students. This is how you do a cluster sampling. The non-probability sampling is when you don't get a chance to do random sampling, or it's not practical, it's not possible. So we always want to have a random sample, because random sample is more likely to be representative of the population. That's what we want in any kind of sampling. But sometimes it's not just possible. So we have a convenience sampling that's very frequently used, especially in education, because we are stuck with intact classes that we can't touch them, we can't move students to assign them into different groups. So we use like the group that we have access and it's convenient for us. And a similar method is a convenience sampling that has a specific proportion. We call it coda. The coda sampling is when you, again, like a stratified sampling, random sampling, you want to have like 33% white, 33% black, and 33% Latino, equal proportion of white and black and Latino students. But this time you don't do it randomly, you just do the available white and the available black and available Latino students.